another computer. Good evening, everyone. We welcome you this evening to another computer engineering seminar organized by ACES. Today's session is on Linux in new digital transformation for the finance industry. We hope to give you an understanding of the new technologies that cloud and DevOps have brought into the corporates. In the discussion, we will also learn of how the finance industry at present is working towards producing the best outcome and role of a Linux engineer. Our speaker at today's event is Mr. Jeevan Abesekar. Mr. Abesekar received his Bachelor of Sciences degree from the University of Peradeniya and his MBA degree from the University of West London. He's the team lead of post-trade Unix support, London Stock Exchange Group. Thank you, sir, for accepting our invitation and being here today. We are delighted to have you with us. Without much ado, let us begin today's talk. Meanwhile, if you do have questions for our speaker, you may raise them at the Q&A session in the end. There will also be a Padlet link on the chat now. You can use that too to ask questions while the session is on. With that, I now hand the session over to Mr. Abesekar.
Thank you so much, Shadi, for the introduction, nice introduction. So, first of all, I have a sharp cutoff at 7, Dr. Damayanti. Because my working hours are from 1:30 to 10:30 in the night, so I have a meeting at 7 o'clock. So I'll drop off at sharp at 7. So we'll manage time accordingly. So because good evening, everyone. Before I move into my presentation, I would like to do some brief understanding what finance industry currently I'm in. So my initial understand was discussing some internal information was something that having some restriction for our side, and LSEG is normally operating from UK, and they are mainly into finance digital platforms. So their main business is providing finance digital platform for trading environments, post trades, and trading pre-trades. So in our organizations, there are multiple companies. They are into different businesses, but all of them are comes under finance industry. So today, my thought was while this and with that note, I would like to show the pathway, what kind of things industry is looking from you, especially finance industry, and what are the avenues you have. So let's move to the presentation. So here I would like to discuss the key topics like what are the digital innovations which disrupt all the industries in present context, and the second one is why cloud and DevOps are key for finance industry. and role of Linux engineer or system administrator in finance industry in current situation, right? So all of you know, with the computer power and their the exponential growth, the computer industry has dominate all the industries now, because we know that this slide is taken from one of the university, US university presentation, and this prediction was done at in 2011, but still it's valid, because they've identified that in 2023, so computer power going to surpass brain power of a human in 2023, and even 2045, the computer power going to surpass brain power equal to all human brains combined. So you can understand how processing power is comes to the world within next 20 years, right? So with that, I would like to get this quote from Microsoft CEO Satya Nadella. So this important quote from Microsoft CEO saying, every company is now a software company. What it means? So assume if you go to a bank in Sri Lanka, if you go to a branch, inside the branch, you can see multiple departments, right? Credit department, deposit department, front office, back office, but every one of them in front of a personal computer or a laptop or a handheld digital device. Why it's that? Because computer has dominated companies, all the industries. I just took up one example as a bank, but you can think whatever company, whatever industry, go and see what happened. So every information is captured through digital devices, and they're going to store in different formats, and they're going to process those things, and they're going to get insight out of those information. So in that sense, this quotation is very valid. And understand of why this kind of digital innovation is very important, is very valid, because every company has their own strategies. So for example, our company has their own strategy, and why we put our strategy, because we need to get ahead of our competitors. Think of normal manufacturing company. So this is a diagram or a picture to understand how we can bring value to our customers, right? So understand these top supportive parts. So they are having 4 parts on top. And think about a manufacturing company. So in a manufacturing company, you have firm infrastructure, like management is there, finance division is there, legal division is there, planning division, and HR division is there. What they are doing is they are hiring people, they are providing trainings for employees. And another important support activity is to bring value to companies technology development division. It comes under, normally it includes engineering, IT, and special skills. And last one is procurement, to bring material inside your organization and manage all the procurement activities. So these are the supporting activities. Those supporting activities can provide value addition to the basic activities, primary activities. Primary activities like in a manufacturing organization, inbound logistics operation is there, outbound logistics is there, marketing and sales and services. So these are basic pillars. But if you think of technology development area, so that particular supportive activity has dominated all other 8 areas. That's why IT and engineering is very important for each and every company. Say, for example, so inbound logistics and outbound logistics use supply chain management system. HR need their HR system. Finance need their finance systems. All are software. Legal team needs their own IT systems. Procurement need their own IT system. And business team, marketing team needs business intelligence systems, very sophisticated systems. So all are softwares now, and their people are getting, industries are getting all the digital touch point into their storages, and they do processing inside their organization to get some insight out of that. So in that sense, so that technology development has gained a lot of admiration at each and every organization now. Right. So, but what I'm good, you know that now with that previous slide, so IT has gone into a huge distance, and now IT is capable of providing more value to organization, and they can create more value to customers. So, but with the speed of the computer power, we have identified that in not only in our organization, in all of organizations across the world, the past software development method have not gone into that much of expert levels with bringing business requirements into clients. Say, for example, so you know that I think you have done your software development module at the moment. So you may have done it, and you may have heard waterfall method, right? So what waterfall method does is, during the software development life cycle, so that was the earliest method before 30 years ago. So we use this software development life cycle method. And initially what we did, we gather all the business requirement, and after that design the business requirement, and after that, after design is completed, we pass into the developers, right, for them to code. Then they do their coding part, then they pass to testers. Testers mean QAs, to do their testing part. Then after that, we deploy it to production or whatever the environment we require to access for client. But the problem here was, it took long time. Normally software project takes minimum 1 year. Some projects took more than 3 years. But if we keep assume we get we're going to gather info, customer requirement today, and 1 year time we are providing solution for them. Most of the time, according to industry research, 92% the time customer requirement can be changed with that time period. So then software developers and the industry has identified a new method called agile method. So agile method means initially do the design, and we can do coding for certain important business requirements. So we pick a key important business requirement and do the coding, and we do the testing, and we keep on building our software, and we can deliver it to the staging area, but we can't deliver into the production until everything is ready. So, but agile is only designed to cater customer requirement and developer processes. But agile haven't had any processes for operation teams like infrastructure teams, network teams, database teams, middleware teams. In our environment also, there are some services still runs on agile, but operation teams work in their silos. Developers and business teams work in their silos. Then what happened? Those silo working environment definitely break our synergy, and we can't meet most of the time our required timelines. And sometimes with those silo environment working fashion, sometimes project may can drag more than expected time period. So then DevOps come into the picture, right? So DevOps means we get the requirement, we identify key important business points, and we do the coding. Then after that, we do the testing, and then we can deploy it. Because DevOps cover customer and business, developer and operation teams perspective as well, right? The whole purpose of this DevOps methodology is to reduce the cycle time, right? Understand the important concept. So why we need DevOps? To reduce the cycle time of bringing a business requirement into production is the main important activity, main important part here. Why DevOps is very important for industries like finance industry, not even the finance industry. Now, most of the industries, even Facebook, Amazon, Netflix, and most of the IT businesses, internet businesses use DevOps now. Their cycle time is less than 1 hour. So if you get a business requirement, designers do their work, and they do the coding with their development teams, then move to the production, and they can deploy within 1 hour. There are some cases Facebook has done such a releases, but think of this kind of environment. So where we get business requirement just now, and we were able to cater that business requirement within 1 hour. So how quick is it, right? Right. So what actually the problem we had in the legacy environment? Legacy environment means we have separate development environments, we have separate operation environments. So they have their silo working patterns. What I mean, with agile and whatever what happened earlier, development team do their development work, they write their codes, and they just pass to operation teams, right? Then what operation team do, they deploy on their environments. But to deploy environment, operation teams has to do a lot of things. What are the main important things? We need to bring down servers, and we need to design the data center, and we need to lay out the network architecture, and we need to design firewalls, require gateways, and we have to do a lot of things at the operation side to bring one application into production. Not only that, they have separate teams. Like as I mentioned earlier, in legacy environments, we have database teams, we have system teams, we have network teams, we have middleware teams, and these teams work together, but they are very rarely work with development teams. So with that, this kind of environment, normally blame game is normal thing. So what happened when client or the customer complain about their software, what happens? So they just push those blames to different teams. So development team says they are pointing at the QA teams. QA team say, no, we did a fantastic job, we tested everything, but it's the problem with IT operation teams. So IT operation teams like system teams, network teams, database teams, they say, no, everything is okay from our side, but it's a problem with your code. And they pointed at the development team, right? But finally, what happened? This environment is not healthier, and it takes long time to build a research requirement to production. So that is the main challenge here. So with that, with the DevOps, we have identified a new concept called CI/CD. So CI/CD is the physical layer implementation of DevOps, right? So nothing but physical layer implementation of DevOps. What actually we'll do here, we segregate continuous integration part, continuous delivery part, and continuous deployment part. I'll explain these things, but in continuous integration, once developers have built their code, they push into the build platform, then QAs and all the testers test their codes, the newly built code, then we merge into the repositories. Then those repositories automatically move into deployment environments. Like you can deploy into pre-production environments, you can deploy into the member test environment, and finally, after all the testing, you can move to the production. But challenge here is the time, right? So what is the major factors or drawbacks of earlier methods, waterfall and agile? The cycle time, how long it will take to bring business requirement into production without failing our existing environment. So that is very, very important. We can provide speedy procedure to bring our code into production, but we have to have 100% sure about the reliability, right? In finance industry, even though we use DevOps, we mainly focus on our reliability, our security, our compliance, then speed of delivery or the cycle time. So we can reduce cycle time in finance industry, but we have to have 100% sure about all the all individual elements are properly tested and measured. Otherwise, if something goes wrong, it will definitely affect our reputation of our company, right? But target here is, so target, and the final target here is, assume a company have fully automated CI/CD pipeline. So to make a fully automated CI/CD pipeline, need a lot of effort from engineering teams, especially IT teams. You can't do it in one night. As well as it needs a lot of cultural changes within our environment. Assume if it doesn't affect for startups or newly built organization, because you can start from CI/CD pipeline and you can bring all the new technologies. But the problem here is the existing organizations still were in legacy environments. So moving to CI/CD pipeline and make it fully automated is a challenge for them, because tools can be, we can purchase tools and get anything, but the problem here is dealing with people, right? So I'll explain what are the key components in CI/CD pipeline. So still we haven't come into the Unix part here, but I'll explain what currently what industry is moving to, and where our, what is our role here is, and I'll explain in later slide, right? So here, developers develop their code and commit to the repository. Then after that, CI/CD pipeline gets started. And during the CI/CD, first we build the, we get the release and we build the code. Then after that, we send it to the unit testing. So QA developers do that. Then we do integration testing. Like there are a lot of integration testing, but each and every point we can automate with different kind of tool sets. And under integration testing and those testings, we can include our security testing as well. Especially finance industry, more keen on security issues. So in our environment also, in our company, they are really keen on security testing. So we have platform for vulnerability scans, and they are directly connected to the CI/CD pipelines, and process is very smoothly implement into this CI pipelines. So no one need to worry about the testing. So after the testing, we'll get nice reports, and if it is failed, it will move to the relevant team and to do any modification. Most of the time, if any security issue pop-ups during the testing, so then it will automatically move the developers, and the developer who developed that particular code will get a email, will be receive an email, and that particular developer can even look at it and open and see and correct it, and they can push it again back to the build environment. So that kind of automation is available now. And the next part is CD part, continuous delivery part. That is the part where we get the tested code. It can be artifact. So there are different few names there. We call it as artifact. So that artifact is a software repository, a software code. We can bundle with the OS, and we can install on top of operating system, and we can bring up the systems, and we can start our second level testings, right? Then after this repository and reviews thing, so we can move to this staging area, whatever the code we have in the pipeline, and we can do whatever the testing we want to do. Then after all testings are done, we can put that code into production. Even putting into production, we can automate through CI/CD pipeline, right? So now you can understand how many, how important that pipeline, because everything is automated except coding. So then is there any possibility to lose our jobs? Even system administrator, if everything is automated, is there anything is there any chance of losing our jobs? Actually, no. What we did 10 years back has changed now. That is the thing. So earlier what happened, so we brought the hardware into our data centers. We install Linux or whatever operating system, Windows or whatever operating systems. Then we add required packages and we install software on whatever the application on top of that. But there are a lot of manual work involved with that. But with CI/CD and DevOps, we can avoid those manual interventions, user manual interventions, and we can automate as much as possible. So that is our objective, and this objective is well identified by each and every business now. So that is the most important thing, because business want to get their requirement into clients as much as possible, means they can get more profits. You know, if we can provide any feature within 2 days to the customers, then business is happy, and even the customers are happy. Then customers come to us rather than going to others, right? So here you can see CI/CD is the physical level implementation, and DevOps is logical level conceptual requirement for to manage people, right? So CI/CD is the physical level implementation of DevOps, and DevOps is the actually DevOps name. It's it's like a culture. We can say it's a DevOps is a culture, or we can say DevOps is a philosophy. So what it focus, CI/CD mainly focus on software-defined lifecycle, and they are highly integrated with tool sets. And to bring CI/CD into the optimum level, you need more automation, right? We should try to automate anything we can, right? Then we can reduce the cycle time of this pipeline. So DevOps, as a DevOps concept, so what we are focusing here, culture, how we can bring a culture where development teams and operation teams can work together. But the plus point here is DevOps tool set is capable of enabling that culture. That is the beauty of DevOps and CI/CD. So earlier, what operation team does is they do their own work, and what if they see any errors, you just pass to the development teams, right? But with new tool sets, all the issues and the places where it has happened is visible to development teams and all the operation teams. So that is the beauty of new technology, right? And second thing is highlighting, which highlights the roles. What are the new roles we require? Whether we need just system administrator or system engineer, whether we need all Linux engineer. So it is now been questioned. So 10 years ago, what we have done with system administration or system engineering has been completely revolution with these new technologies. Even as an engineer now, we should have to have more responsiveness, and we should be more collaborate with all our peers. Otherwise, you can't survive in a DevOps environment. That is a very important thing. You normally we know that the different cultural background, so people try to keep their own part, and they just throw only the list information to the other team. So that is normal culture in most of the organization. But with DevOps, we need to break those silo environments, right? Right. So now you can understand why we need DevOps and cloud, because cloud is the main enabler to bring those technology inside into the environment. So without cloud, we can't do any of these DevOps achievements in legacy server-based, hardware-based environments. So you need, first you have to move to the cloud. Then after that, you have to bring those tool sets under CI/CD. If you still live in the old legacy hardware, so there's no point of doing that. Okay, right. So first thing is, now under cloud, so there is a main important thing for system administrator, Linux administrator. So under cloud, you know that AWS is a popular cloud vendor. Azure is a popular cloud vendor, and Google is another popular cloud vendor. Normally, you can create your own account using any of these cloud platform, and you can just log into that portal, and you can create your own virtual machines, and you can build your data center within the cloud platform, right? It's very easy. It won't take much time. But in enterprise level, you can't go each and you can just log into those web browser. It's a web level portal, right? Normally AWS portal is just a web level portal. You can't go to that that web portal, and you can't create thousands of VMs, thousands of guest operating VMs on those platforms, right? Because what we mentioned in CI/CD is we need to automate. So we have to write some scripts to build our infrastructure. So we call it as infrastructure as code. What it does, it is capable of creating each and every individual host, network, whatever the load balancers you need, anything you can create through command line, but not command line, through scripts. So Terraform is a software where we use to create those infrastructure, right? Terraform is a multi-platform software, so you can connect to any cloud platform, like famous cloud platform like AWS, Azure, and Google. And through APIs, you can call and you can create those infrastructure using Terraform. So it's a very beautiful software. So if you have time, so you Google it and see what is Terraform is. And it's a cross-platform tool, right? There's a language called HCL, HashiCorp command line language, and it's a very important scripting language to build infrastructure in cloud. Another famous one is CloudFormation. It is also similar to the Terraform, but it's a proprietary for AWS, Amazon, right? Cloud. The next important success factor is integration and delivery, right? I mentioned that. And important tool sets are Ansible, Puppet, and Shell script. But here, I think now Puppet is very old tech software. Now most of the organization move to Ansible and Shell script, right? I will explain Ansible in detail, but let's move into this other areas where how we can improve our DevOps journey with those success factors. Another important success factor of DevOps journey is continuous testing. So every time you do, you have to have proper testing mechanism to test security and compliance, especially in finance environment. So we really keen on these testings, and we thoroughly look those testing scripts as well. And you can use different tool sets. I'm not going to list those tool sets here, but so security testing is very important. But each and everything has to be put into a script or a piece of software code. Then you can integrate with your CI/CD pipeline to automate that. Okay. The last thing is, and it's very important thing to monitor our systems, production systems, or whatever the deployed systems. So Nagios is a tool to monitor those systems, and there are multiple app monitoring systems also available, but these systems, these monitoring tools are very sophisticated, and even it provides a lot of information to the different teams to act upon based on the events. Okay. I mentioned about the CI/CD pipeline, but the actual tool which is used to orchestrate that CI/CD pipeline is Jenkins. So Jenkins is the tool. Actually, Jenkins is the famous tool to create, which is used to create a CI/CD pipeline. And even in our environment also, Jenkins is the tool we use. And we can map all those pipelines, like we can map all those points into Jenkins pipeline. So first we create build pipeline, build function, then we can integrate testing functions, then we can integrate integration testing, security testings, and we can integrate all those steps into Jenkins pipeline, right? So Jenkins is the tool we use here, right? But these tools are very important for system administrators, even for Linux administrators. Yes, we need that. Ansible is very, very, very important for Linux administrators, right? I'll explain brief about what is Ansible. So, and I'll end up my session. So, but this is very important to understand the concept. So now, rather than just going to the systems and do configuration is not the way of doing IT now, or in system administration now. So we have to code everything. So Ansible is a tool where you can use to build our own systems through codes, right? So Ansible can be used to provision systems, and it can be used to do configuration management, application deployments, and it is an infrastructure as a code tool, right? The beauty of the Ansible is it can run on Linux, Solaris, AIX, whatever, and even it works with Microsoft. Why? Because it uses SSH protocol to connect those systems, and they can run whatever the scripts required, right? So I'll briefly explain what is Ansible tool is. So the setup for Ansible is just a few commands. It's very easy. You just take up a Linux machine. Even it may be helpful to build your infrastructure inside your for your project works as well. If you have a free AWS account, so you can just you can log into AWS account, and you can freely create your own environment, right? If you have a credit card, yes, you can easily create your own account. And Then after that, you can create few virtual machines with Linux and install Ansible on one environment. It's just a few commands, like you can execute yum install Ansible and you can get this particular node. It's called Ansible management node. And after that, we have to manage a host group like this. So it's called inventory. I'm not going into detail with that, but it's like you can whatever they manage the node through this management node can be put into your inventory like this. It's like host. We can give whatever name you like. So here I put another example here. You can create an inventory like here. Group A contains host 1, group B contains host 2 and host 10. It's just an inventory, just a file, right? And this is another example. So inventory file like web servers, 2 machines is there, web 1, web 2, app server, 3 app servers there, DB server, DB1, DB2. And the where we write those code is under playbook, right? Assume you want to install HTTP. So this is the basic, right? You know that you want to install HTTP software on in web server, right? So assume it's called web server. So what you're going to do is you just log into the web server and you just install yum install HTTP, right? Rather than doing it, how you can do it via Ansible? It's you can use Ansible command. They're called Ansible ad hoc command. So Ansible, give the machine name web server, because web server should be in that inventory file, right? If a web server is there, I assume it's a web server here, name as web server. So then you can execute Ansible web server -m, and you can provide the name HTTP and state equal latest. So then it will install latest HTTPD service into this web server. So if you put into the Ansible playbook, it will look like this, right? So it's a playbook. It's save as Ansible. Install underscore web.yaml. It's a YAML file. We call it as a YAML file. So just put detail like this. Name. You can give whatever you like, and you have to put host. We mentioned that web server. Then that is actually the coding how you do it for Ansible. Then you put task, and you have to give the module name as yum. Then give name equal HTTP, state equal latest. Then you have to run this command Ansible -playbook in Ansible -playbook install underscore web.yaml. What will happen? We are running it. We can run it. We should run it on this Ansible node. Then it will install Ansible HTTP package on web server. I think you got that point, right? So it's a basic playbook. So I'm not going to detail on that. Now you know that. So here details are there. So here what this is. So ensure Apache is at the latest version. So normally the install method. So yum is the module name. We can give name as HTTP. Then check this status as latest. If it's not latest, it will upgrade to the latest. Then there's another module called service. Name it as a HTTP and status as started. If it's not started, it will automatically start the HTTP service. So like this, you can create users. You can create whatever you do through command lines. You can convert it into a code, right? So Ansible is the way of doing that. So through this, you can automate whatever you like. And right here, you can see there's module called user. You can give username, which groups are belong to, and what cell is, and what is the home directory. Right? It's very simple. if you do it through command line, you have to use add commands, right? But Ansible has their own modules, and documents are available in internet. You can go to internet and you can get those details without any issue. So I'll skip those things because I have to sharp cutoff, but that I can go up to 7:15. Right. I'll skip this one, but I would like to mention that Ansible, that playbooks or whatever the technology can be used on host Linux or Windows, whatever Unix flavor, and even we can do modification on network systems as well. Network device like switches, routers, firewalls, anything like that. Okay, so we can automate anything within our environment, right? So this is the important slide where it's contain Ansible architecture is here, and there's another plugin called Ansible Tower. So Ansible Tower is enterprise level tool, so where you can create role-based access for users, and you can do a lot of scheduling to Ansible Tower. So you, if you are interested about this technology, so you just Google and you can get all the information required. But the beauty of this tool is you can automate your enterprise systems, Linux, Windows, Unix, whatever. You can automate your network systems, containers, so Docker is LXC, and Kubernetes also there, and you can connect to any you can work in any cloud platform. That is the beauty of Ansible, and you can work with any services. So there are more than 1,000 plugins are available. So with that you can do whatever use case like provisioning, and Ansible can be used for provisioning, configuration management, application development, continuous delivery, security and compliance testing. Also we can use Ansible, and orchestration, right? So as a last slide, I put this one. If you like to be a system engineer with Linux, or there's another role which defines under DevOps category. It's called site reliability engineer. It's a new one, new job role. If you have time, so you go to the Google and you can get information. It's a site reliability engineer. It's a new job position. It's not exactly the system administrator, but there are things we need to work with application teams and with production systems, how we manage those things. It's a kind of job role. Lot of organizations are looking at with DevOps and cloud. And key certification like because I prefer with the Red Hat, so, and even our environment use Red Hat as operating system, and Red Hat certified administrator is the best pathway to where you can start with, and Red Hat certified engineers and next available operating system related Red Hat related certification. And there's another one called Red Hat certified specialist in Ansible, and the middle part is mainly for cloud related certification. So AWS certified solution architect associate is my preferred one, but there is another certification called associate Google cloud certification, and there's another certification called Kubernetes administration. So you just note this down and you can see what type of specialization you can gain with those certifications. Right. Thank you. So any questions from your side? Hello, Dr. Damayanti.
Yes, Jeevan, we can hear you.
Any question from your side?
Nothing in specific, but I was thinking maybe you can emphasize on, you mentioned a couple of certifications that would be useful.
Yeah.
So what sort of are they in a position to take these now? Will they have access to these courses?
Yes, this certification is available, so you can go to the first certification set is from Red Hat, so you can go to redhat.com and you can get more information. And testing, the examination centers are available in Sri Lanka, so you can, student can go and get that certification. But there are different trainings also available, and most of Sri Lankan institutions also now doing their own training sets in for these specific certifications. You can get it, even cloud certifications also available. So you have to pay through internet, and you can book time for that. And training courses are also available with that.
Sadia?
Anything else?
Hi, I have a question. So there are 3 vendors when we are deploying a CI/CD platform pipeline.
Yeah.
So in your experience, can you explain which vendor to start first as a beginner?
You mean vendor means a tool, right? You mean?
The AWS
Yes.
and Google.
Yeah, I think better if you can go with AWS, because AWS is the most, which Amazon is the most preferred and most widely used around the globe. So anyway, that Azure and also Google also capturing, GCP also capturing their market, but maturity level, I say, I think AWS is the best, because their certifications and their training courses are very high level compared to other 2 competitors. And there is a I don't know whether you have already have experience with that. There's a learning platform called Udemy. Have you ever heard that? Udemy?
Yes.
Yes. In Udemy, there are a lot of courses available. Some of them are paid courses, but there are a lot of free courses as well. I prefer Udemy actually. Yeah, Udemy is it's the best place to get a lot of good courses for AWS, even for Red Hat.
Thank you very
Okay.
much.
Any other questions?
I guess for now, there aren't any questions in the chat, or I don't think anyone has any more questions. So thank you, sir, for speaking to our students this evening. We are grateful for the time and effort you took to share your thoughts and also your experiences with us. As we are entering a new phase of growth in our country and also in the world, your comments were very timely. We hope to hear from you again soon. Thank you again for your contribution.
Right. Thank you so much for everyone who participated for this session, and thank you so much, Dr. Damayanti, for organizing this this session. So I think there will be another session from our company for especially for DevOps. Not sure when it's be scheduled, but you can get some exposure, more exposure with him as well.
Thank you, Jeevan.
you.
It was very nice having you in this evening. Thank you. We
Right.
keep in
Thank you.
touch.
Good evening to all. Thank you.